Okay, so today we're going to talk about closure properties of integers and polynomials. The first thing I want to talk about is this word closure. What does it mean when we say something is closed under an operation, specifically addition, subtraction, and multiplication? Okay, so what does that mean? And division. I forgot that one. Okay, basically what this means is if I apply one of these operations to, and we're going to focus on integers to start off with here, okay? So let's put integers down because that's what we're going to start with. If I say, okay, I want to know if something is closed under addition, subtraction, multiplication, or division, and I'm specifically talking about integers, it's asking me if I take two integers and I add them together, will the result stay an integer? If it stays an integer, then it's closed, it's contained, okay? If I do a division and the result is not still an integer, then it's open or not closed, meaning it's been able to escape out of the set. So let's go over to this graph to the left here and look at this. This is something you've seen before, okay? I put a box around it because all of these numbers are actually real numbers, okay? Everything here is a real number. Now, these real numbers are broken into different categories: rational, integers, whole, natural, and irrational. So we're going to deal with this category right here, okay? The integer category. Let's take two integers. Let's call them 3 and 2. Okay, so the integers 3 and 2, if I add them together, results in an integer of 5. So the two integers that I added together created another integer. Therefore, it's closed under that set. There's no other combination of these integers, such that it would not stay an integer in terms of addition. So we can say here that integers are definitely closed under addition. Let's look at some subtraction here. 3 minus 2. Well, that's equal to 1. So I started again off with two integers. In this case, 3 and negative 2 were the integers, and the combination of those two created 1. All right, everything's still an integer, so it's still closed. So we are still closed under subtraction because there's no combination that you could create here that wouldn't lead us to another integer. Let's try multiplication. 3 times 2 equals 6. All right, well, that, again, two integers, 3 and 2, multiplied together, that creates 6, another integer. So multiplication is closed under, integers is closed under multiplication as well. Finally, we need to look at division. I'm going to change some of the numbers. I'm not going to change the numbers yet, but then I will change it on the latter half. So I'm going to say 3. I'm going to put this in red actually. I'm going to say 3 divide 2. Well, 3 divide 2, that's 3 halves. That actually doesn't work for us because 3 halves is no longer an integer. As a matter of fact, 3 halves is a rational number. So it sits up here, which means I took the number 3 and I combined it with the number 2, and together those broke out of the integer set and fell into the rational set, which means it is no longer closed under that set. But if I did 3 divide 3, I would get 1. So wait, sometimes that would be rational, and other times it would actually be an integer, right? So 3 divide 2 created a rational number, but 3 divide 3, 3 and 3 are both integers, and the result became an integer again. So therefore, that is an integer, which means it's closed. So in this case, it's closed here, but it's open here. which means is it closed under division? Well, not all the time. So what we would say is it is sometimes closed. Okay? Go ahead down to the next video. We'll talk about polynomials there. Okay, so we're going to talk about closure properties of polynomials at this point. Closure properties of polynomials is basically the same as what we talked about in integers, is if we add two polynomials together, will it still remain a polynomial? If we subtract, will it still remain a polynomial? If we multiply, will it still remain a polynomial? And if we divide, what happens? Okay. Now, what we want to look at here is this. First off, let's redefine what a polynomial is. A polynomial has some subcategories. Let's start there, actually. But basically, a polynomial is an expression that has terms in it. Okay, typically several terms that contain different powers of the same variable. But specifically, we know that these are called, we can have monomials, binomials, and trinomials, right? And we know monomials have only one term. So that would be something that's like negative 5x or 4x squared. Those are just single terms. Binomials have two terms. And would look along the lines of, 5x plus 2, x squared plus 3, things along those lines. Trinomials are terms that have, it's a polynomial that has three terms. So it's more of what we're used to seeing, which is something like x squared plus 2x plus 4, right? And that would be a trinomial. Now, when we, again, the question here is, are these closed under addition, subtraction, multiplication, and division? Always, sometimes, never. Okay, that's the idea here. So if we look at addition, and let's just take 5x squared plus 2 minus 3x squared. So what we can see here is this is a binomial. This is a monomial. And we can see here that because of these two, if I combine the x squareds, I'm going to get 2x squared plus 2, right? And this result is actually a binomial. So therefore, it's closed. Actually, this is closed under subtraction, so I jumped over to subtraction there. But in the same respect, if I just turn this into a plus sign, the result would then be 8x squared plus 2, and so we know it is also closed under addition. And if I make this a multiplication, right, it's going to also turn into it's going to be a binomial again, and so we can see that polynomials are closed under addition, subtraction, and multiplication. Again, I could find a way to get a division problem. Call it 5x squared divided by x. That's simply 5x. So that shows us that, oh, okay, we went from a monomial divided by a monomial, gave us a monomial, and so this works. But if I do a binomial divided by a monomial, I'm going to get a very strange result because I'm going to get x plus 1 over x. Well, the issue here is in a polynomial, I cannot have a negative exponent. It has to be all positive exponents, okay? They can be, or 0, excuse me. So 0, 1, 2, 3, 4, 5, any of those, but it cannot have negative exponents because that kicks it out of being an actual polynomial. So therefore, yet again, under division, it's sometimes closed under division, okay? So, add, subtract, multiply, always closed under add, subtract, multiply for polynomials, and sometimes closed under division.